So this is the discussion of the Module 6 entitled Data Link Layer. In this module, we are to cover functions, components of the data link layer. We look into some of the topologies that we have in a wide area network and local area network, and we'll discuss data link frames. So again, the data link layer is the second of the lower layer. It is connected to the physical layer. We've covered during our OSI that there are two components under data link layer. We have the LAN card and the switch. Okay, uh, so the data link layer is the one, like specifically the LAN card. It is the one that where our cables is connected. So one function of the data link layer is to um, prepare the uh, frame during bit transmission. Okay, that's one function of the data link layer. Uh, there's a specific function in the data link layer in terms of preparing the signal going to the cables. It has a role or function of the encoding and the signaling mechanism. Okay. Um, Another, if say during receiving, if the data is to be passed on the upper layer going up, function of the data link is to also prepare the frame to its upper layer, network layer, okay, which is the network layer. Okay, so take note the data link is in the middle of the physical and of the network. So there's two functions when we talk about data link layer. Function of preparing the frame going to the frame is the encapsulated data in the data link. Preparing the frame going to the physical and preparing the frame going to the network layer. Okay. Aside from those functions that I talk about, preparing the frame to the physical or to the cables, like encoding and signaling. Other than that, other functions of the data link is error detection. Take note, we mentioned during the discussion in the physical that errors are being encountered. Okay. Um, and there are mechanisms that can detect errors, and LAN card has that. Okay, LAN card also has a way to um, deal with corrupted frames, and that is rejecting it. So IEEE has standards in relation to data link layer. Okay. Well, in fact, as I mentioned, the data link is in between the physical and network. So what IEEE did with the data link layer is it divides the data link into two sublayers, LLC and then the MAC. Okay. LLC, if you notice, it's on top. Whatever functions that are there in the LLC, it has something to do with preparing the frame going up, going to the network layer. Okay, the ability of the data link layer component, say a LAN card, to recognize network layer protocols, say IPv4 or IPv6. These are all um, these are all written in the LLC sublayer. Okay, that is the role of the LLC sublayer. While the MAC sublayer, MAC stands for Media Access Control. It is the one responsible for um, say data encapsulation, media access control, and in general preparing the frame, okay, from this data link going down, going to the physical layer. Okay, so again, LLC is going to the network layer, MAC is to the physical. Aside from the what I just discussed a while ago about the LLC and MAC, there are also other protocols under data link layer developed by these organizations, ISO, ANSI, and ITU. Uh, and then we look into the topologies. Again, we have two types of topology, physical and logical topology. Okay. Um, if if you have a floor plan and you lay down specific position positions of your devices, these are end devices and your network devices, and you specifically lay down draw, okay, the proper position of or location of your cables in the floor area. That is an example of a physical topology. Of course, there should be labels. Okay, observe proper labeling. Um, Cisco has a separate training program where network design is discussed in detail. That is CCDA, Cisco Certified Design Associate. Okay, so our agenda here in this discussion is just as an overview of what physical and logical topology is. Okay, a logical topology defines data flow. We will be familiar a lot with logical topology because we are to um, we are to work on network topologies a lot because we'll deal with configurations of switches and routers. Okay, so um, like the exercise we had last time, that is one example in the packet tracer. That is one example of a logical topology. So in the logical topology, it shows how network devices are connected, okay, together with the end devices. That's the whole agenda of the logical topology. Its basic function is to merely define data flow. There are common topologies. In my opinion, is concept. No, one topology concept. So there's this what we call as a point-to-point topology. Okay. In a point-to-point is there is a dedicated connection from one node to another node, or say from one router to another router. In a real scenario, it's like from one branch to another branch. Say Mapua Makati to Mapua Intramuros. Say its connection is a leased line. Okay, we will discuss this line in module 3. So, Cisco module 3. So, if it's a list line, there is a dedicated connection from one campus, say Makati campus to Intramuros campus. That is one example of a point-to-point. In hub and spoke, it's similar to a star. In a star topology, you have a central device, and these central devices are where other nodes are connected. Okay. So like in one topology, one good example of a hub, there is this legacy wide area network technology we call as a frame relay. So in a frame relay, say like a bank, say BDO, okay? And let's say BDO branches are connected to through this frame relay network. So in a frame relay, there is a frame relay switch. Okay, it sits in the service provider. It is in the service provider, and this frame relay switch. These are where other branches are connected. These are where BDO branches are connected. So it uses that hub and spoke. Okay, we call that again as a hub and spoke. A mesh, like example BDO branches, if each and every other branches are connected together, so that's an example of a mesh. Okay, very expensive, but good thing is it provides high availability because there's too much redundant connection. Okay, so again, in a point-to-point like this, I have a scenario here. Say example, given this is node 1 is Mapua Makati, the other one is Mapua Intramuros. There is a dedicated connection, okay, connecting these two branches. So we call this as a point-to-point. Okay, there's no other network devices. There may be a network device like a multiplexer, but then again, it just terminates the wire to connect this node 1 going here directly to node 2. Okay? Uh, there. So, also we have topologies in a local area network. So, we have the bus. This is a legacy type of a topology. In a bus, you have a single backbone cable made up of coaxial. And this one, we call this as a T connector. It's a T connector, like a splitter. Okay. I suppose you know what a splitter is. You buy it in the hardware. Let's say you subscribe to Sky Cable and you have 5 TVs at home. You want to connect the cable line to all of these 5 TV. You buy a splitter. Similar to this one. Okay. So you connect all your computers there on the single backbone together with the T connector, and then you have a terminator here at the ends of the cable. Okay, the terminator, this one we call this, the circle one, we call that as a terminator. It prevents the signal from bouncing. Okay, That is the old way of connecting our computers. That's the first, actually, that's the first way we connect our computers in the history. Uh, Problem with that is it's not scalable. If you have many computers, say for example 1,000, there's no way the traffic can be managed. Cables do not have a means to manage the traffic. So you expect too much congestion. Okay? So after the bus, then next is the ring. Okay, in a ring, okay, it has two LAN cards. Physical ring, ha. In a physical ring type, there are two LAN cards. One LAN card is connected to the other, and then until it will form a ring. Okay. The good thing with this physical ring is, uh, if if there's a disconnection on this part, still you have an alternative path. Not like with the bus, if the backbone cable is damaged, then you don't have any network. Okay. Nowadays we are using a star. Like in the star, there is a here in the middle you have a hub or a switch. Okay. So this switch, it's a network device that can manage our network, and these are where our end devices are connected. If you have two or more switches, we call it as an extended star. Okay. Um, Later we'll cover media access control, and there's also what we call as a logical ring. Okay, a logical ring, uh, topology. It's a token ring, and logical ring topology is used by this token ring technology. We'll discuss that. We'll discuss that further later.